Good afternoon, Cappuccino. Sorry I'm so late in getting my assignment up. I had to help my son try and register for housing for a college next year, and it didn't go so well, so I'm a little irked by that. But anyway, time to carry on. Today we are going backwards. We are going to do the inverse normal distribution. So that means we know the probability of something happening, and we want to figure out, well, what was the thing that was happening? So if we know the probability, and we know the mean, and we know the standard deviation, we can find the x value. Okay, so we were looking at situations before where we want to know what's the probability of selecting somebody who is, say less than 20 years old at a shopping mall, and we know the mean and the standard deviation of ages of people at the shopping mall, and we're trying to figure out what's the probability of picking somebody who's less than, say, 20 years old at the shopping mall. We were doing problems like that before. Now, I know that the probability of picking somebody at the shopping mall is 80%, say that, and I know that the mean at the shopping mall was 14, and the standard deviation would be the square root of 49. That would be 7. So I want to find out, well, what age was I talking about? What age was I trying to pick that gave me a probability of 80%? So I'm trying to figure out what was my problem? What was my question? What was I trying to find the probability of? If this was the mean and this was the standard deviation and I ended up with this, well, what was the question? It's kind of what I'm doing. Okay, so one thing is we're going to be using our graphing calculator, and when we put in the probability, when we put in this, if the probability is given to us with a less than situation like this, we're good to go. No problem whatsoever. But if we're given the probability the other way, with x is greater than x, then we need to rewrite it. So if this had said greater than, x is greater than x, we would have to do 1 minus this, which is 0.2, and then we could use that in our calculator. So don't worry, we will do an example of having to rewrite it, but let's go ahead and do a nice straightforward example right now. So first of all, I'm going to make a little sketch of what's going on here. So if I make my normal distribution curve, so if I make a little picture of it, so make a little normal distribution, a bell-shaped curve, any bell-shaped curve will do. I know that my mean right here in the middle is 14. I know my standard deviation is the square root of 49, so my standard deviation is equal to 7. So if I add 7 to that, that would give me 21, and if I subtract 7 from that, that would give me 7. So here's my standard deviation, and it says the probability of the event is less than some number is 80%. So 80% of the area here would probably come up to somewhere over here. I'm thinking 80% of this is probably somewhere around 21. So I'm guessing my answer is probably going to be somewhere around this 21 mark. Okay, so the probability that I select a number here that is less than some number is going to be 80%. So 80% of this is going to be less than some number. So I'm thinking it's somewhere around 21. That looks like that's probably 80%. Maybe it's a little above, maybe it's a little below. I'm not too sure. So that's where we're going to use our calculator. So on the calculator, we are going to go to second bars, okay, where we get our normal distributions. Can we see that okay? And we are going to go to option 3, inverse normal. Okay, inverse normal. So what did I just do? I just did second vars, and then this is option 3. Okay, so second vars, option 3, and that gets me inverse normal. Let's write this in pen. This seems a little light. So we're going to see inverse norm is what we're selecting. And when I select that, let me focus that. It seems a little out of focus. Okay, we're going to put in our, where it says area is this. That's the 80%. We're going to put in our 0.8. Okay, so the area is going to be our 0.8. The mean, well, they gave us the mean. It was 14. And the standard deviation was, remember, it's the square root of this, so it's 7. Okay, so I put in my mean, which was 14, and I put in my standard deviation, which was 7, and then I hit enter a bunch of times. And if you're on a TI-83, I'm imagining you just put these in with commas. Okay, hit equals a few times, and I get 19.9. So this dividing line, x equals 19.9. 19.9. Okay, and that kind of makes sense. 19.9 would actually be like probably about here. And so this is 80% of the area under the normal curve. 80% chance of selecting a person who is under the age of 19.9. Okay, so if given that the average age was 14 with a standard deviation of 7. Alrighty. So we could double check it. We can now run it through normally. We could check it by going second bars and go to my normal distribution. And I want the probability that something is less than 19.9. So my lower is going to be negative like a million. And my upper is 19 because I wanted everything to be less than 19.9. My mean, again, was 14. My standard deviation was 7. And when I do this, I should get approximately 0.8. And there it is, 0.8. So it worked. Yay! I just went backwards. Okay, so there's a very simple one where we're just going backwards. Of course, they're not going to stay simple. These problems are going to get more complicated. So how many problems am I going to do? I'm going to do 4 examples. That's how committed I am to this idea. All right. So the next one, it's going to be a backwards one. Let's do a backwards one. So the next problem we are going to have, so our next example, we have an event that is normally distributed with a mean of 36.5 and a variance of 10, okay, which means the standard deviation is the square root of 10. And I know the probability of this event is equal to 0.9. Okay, notice the probability of the event being greater than the x value is 90%. So that means that wherever my value is, 90% of the curve is going to be above that value. Okay, the probability that I'm greater than some value is 90%. So if I were to sketch this on my normal standard curve, make my bell-shaped curve, 90% of the curve, well, that would be like way over here if I was below, if x was less than 90%. But this says x is greater than x, so the probability that I'm above this number is 90%. So that means the shaded area is going to be above my x value. So it's going to be way over here. My x value is going to be way over here. And this is 90% because the probability that I'm above this x value is 90%. Okay, the probability that I'm above some x value is 90%. So 90% of the curve is to the right of this. But remember, the calculator can only give me less than answers. So I'm going to rewrite this. Okay, so this is going to be 1 minus this guy is going to give me my probability of x being less than x. And that's what we need. We need this to put it into our calculator. So I'm going to say 1 minus 0.9, and that gives me 0.1. Notice that's the complement. Okay, so this over here on this side is 0.9, so the rest of it is going to be 0.1 because together they have to add up to 1. Probabilities have to add up to 1. All right, so now I can do my inverse thing because I know that the probability is now in less than form, and I know that's 0.1. So if you're given it in greater than form, all you got to do is subtract it from 1, and then you're off to the races. And now we can solve for x. Okay, so I'm now going to put this into my calculator. So again, I'm going to do that second, oops, I'm going to turn it on, second vars option 3. Okay, second vars option 3. So that was second vars option 3. And I get inverse norm. and I'm putting in my area is going to be 0.1. My mean is going to be 36.5, and my standard deviation is going to be the square root of 10, because 10 is the variance. Right, so 0.1, and then my mean, 36.5, and my standard deviation is going to be the square root of 10, and hit enter a bunch of times, and I get 32.4, 32.4. Okay, so if we think about it, oh, let me write that down first. So x is equal to 32.4. So if we think about that, our mean was right here. Our mean was 36.5, and our standard deviation is 10. So if we subtract 10 from that, we're going to get 26.5. Oh, sorry, our standard deviation is the square root of 10. I was going to say, gosh, that doesn't really seem to make much sense. Sorry, the standard deviation is the square root of 10. What is the square root of 10? Square root of 10 is 3, about 3, a little more than 3. So, okay, now it makes sense. I was like, God, that seems weird. So here would be like one standard deviation away. Standard deviation is around 3. So if I minus 3 from this, I get around 33.5. And then if I minus 3 again, I would get 31.5, and it makes sense, okay? So it makes sense that that's my x value, okay? So because that looks like about 10% of the area, that's about 90% of the area. If I equally space my standard deviations, it makes sense, okay? So there it is. All right, so we've done one that was set up correctly, one that was set up incorrectly, and we had to find the complement. Now we're going to do one where we have more missing information, okay? So they get a little tougher. So the next one, next example, is we're going to have an event that is normally distributed, and we don't know the mean, but we do know the standard deviation. Okay, the variance is 4, which means the standard deviation is going to be 2. Okay, so we might want to write that down right away. Standard deviation is going to be equal to 2. All right, so and then we're given some additional information. I know that the probability that x is greater than 4 is equal to 0.8. And now I'm going to try and solve for the mean. Okay, so I know the x value, I know the probability, and I know the standard deviation. So now I want to solve for the mean. Well, let's see, how are we going to go about doing that? Do we have any formula that has mean in it? Because the calculator, all the calculator can do is give us x. It can't give us the mean. We have to tell it the mean. So we're not going to be able to do this terribly directly. What we do know, though, is we know that there is a formula for z-score. The z-score has mean, standard deviation, and x in it. So what we can do is we can use that z-score information to help us solve this problem. Okay, so we are going to figure out what is the corresponding z-score that has a probability of 0.8. Okay, so we're going to change this to a z-score. I want to know what's the probability of a z-score having, what's going to be the z-score that has a probability of 0.8. So if I can find the z-score, if I can figure out what z is, I know what x is, I know what the standard deviation is, I can solve for the mean. Okay, so notice we know when we have a z-score, we always know what the mean is and the standard deviation. So for a z-score, the mean is always going to be 0, and the standard deviation is always 1. So now we can use our calculator. But remember, this has to be written in less than form. Okay, so the less than form is the complement of this. So we're going to take the complement. We need to switch this so we can put it into our calculator. The complement would be 0.2 because these have to add up to 1. All right, so now I can go to my calculator and I can find the z-score for this x value. And let's go ahead and do that. Let's see, what is my z-score? And then we're going to be able to figure out what the mean is. All right, so I'm going to go second, vars, inverse normal. I know that my area, or my, what is up with this? Oh, there, now that's better. I was like, why is the light not shining correctly? Okay, so my probability, or my area, is 0.2. My mean, remember we're doing a z-score, so for a z-score, the mean is always 0, and the standard deviation is always 1. Hit equals a few times, and we get the probability, we get the z here, our z-score is equal to negative 0.842 if I rounded to 3 significant figures, okay? So I know, though, if we know the z-score, and we have the x value, we have a formula that puts these all together. We can use the z-score formula. Z equals x minus the mean divided by standard deviation. So I know my z-score is negative 0.842 approximately. And I know my x is right here is 4. I don't know my mean, that's what I'm trying to solve for, and I know my standard deviation from here is 2. And now we can solve this for the mean. So I'm going to multiply both sides of the equation by 2. Since I still have this in my calculator, I'm just going to times it by 2. So I get negative 1.68. Negative 1.68 is equal to 4 minus the mean. Now I'm going to move my 4 over, so I'm going to minus 4 from both sides. So I still have this answer in there, so minus 4. So I get negative 5.68 is equal to negative mean. Divide both sides by negative 1, and I get that the mean is equal to 5.68. And there it is. Okay, and then we could go back and check. We could check it. Notice this is written backwards, so we could switch it around, right? Oh, no, what am I saying? We can go ahead and put this in if I go to my calculator, let's go to the normal distribution. Normal distribution, option 2. And my lower limit, so I want x to be greater than 4. So that means 4 is my lower limit. And my upper limit's going to be like a million, infinity, whatever. My mean, I'm saying my mean is 5.68. We just solved for that. And my standard deviation should be 2. Okay, the square root of 4 is 2. And fingers crossed, we should get 0.8 when I hit enter. 0.7995. Okay, that would round up to 0.8 because we did do some rounding to get this 5.68. So it worked. It worked. Yay, I got the right answer. All right, now, of course, it has to get ridiculously hard. We are going to have the last ridiculously hard problem. There is a situation that is normally distributed, and I don't know the mean, nor do I know the standard deviation. Okay, I don't know either. I do know a couple things, though. I know the probability of having an event greater than 7 is equal to 0.8. And I also know that the probability of x being less than 6 is going to be equal to 0.1. Okay, so let's think about these probabilities. What would this look like on a normal curve? So if I have my normal curve, I sketch my bell-shaped curve. And here's my mean there in the middle. Sorry, that's not a very good-looking bell-shaped curve. Imagine that's the highest point. That didn't really make it any better, did it? All right, so here's my mean. I don't know what my mean is. My standard deviation would go like here and here. I don't know what that is. Okay, so we're trying to figure that out. I do know that x is greater than 7 is 80%. So 80% of the curve, 80% of the area here is greater than 7. 80% is greater than 7. So most of this is greater than 7. So the dividing point between 80% being greater, that means 20% would be less. It's probably somewhere around here, right? Maybe. Okay, so this would be 7. Okay, 80%. There's 80% probability is the same as the area under the curve. That looks like it's maybe about 80%. And then 10% of the area is less than 6. Okay, so this is 20%, so 10% is probably like around here. Here's my 6. 10% is less than. Okay, so I've got 80% here is greater than 7, 10% is less than, and then 10% would be between the 6 and the 7. All right, so we're going to do the same thing we did on the last one. We are going to find the z-scores. We want to know what is the z-score here and what is the z-score here. So this one, I'm actually going to start with a smaller one. I'm going to take this one first. I think I'm going to do that one first. I'm going to just change that to a z-score. I want to know what is the z-score, what is z, if the probability is 0.1. Okay, and I can now do that just like we did in the last problem. I can put that into my calculator and get that answer. Okay, so that's this one right here. And then for the other one, the probability that my z, I want to know what's the z-score here. I don't know. And notice I'm changing it to a less than. It's got to be a less than in order to put it into the calculator. So if this is 80 on this side and I switch this, it's got to be the complement, so it's going to be equal to 0.2. Okay, so we can make a little note there. What did I do? I did, we knew that P of z is greater than z is equal to 0.8, so then I rewrote it. I changed it to a less than so I can put it into the calculator. Okay, so this one came right here, and this one I didn't have to rewrite. I just changed it to a z-score. I'm just trying to find the z-score. So when we put it in for the z-score, remember that our mean for both of these, when it's z-score, mean is 0, and standard deviation is 1. So now I can put this into my graphing calculator. I'm going to do one at a time. Second, vars, inverse normal. And I know the area for the first one is 0.1, and the mean is 0, and the standard, oops, you can't see what I'm doing. The mean is 0, and the standard deviation is 1. Okay, I'm doing this one. Enter, 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 and I get negative 1.28. So my z-score for this one, I know, is approximately negative 1.28. And then I'm going to do it again for the other one. So second vars. Can you see this? I feel like there's a glare. Option 3. And this one is 0.2. Same mean and standard deviation because it's a z-score. And I get my z is equal to negative 0.842. Okay, so, and that makes sense. Z-score, this would be z is equal to negative 1. So I was a little bit off on where the 7 is. The 7 would actually be on this side. And this one, negative 1.28, it's to the left. Okay, so not too bad. So my drawing looks, maybe I was a little bit off on my drawing, but not too bad. Okay, now we're going to do what we did on the previous problem. I have my z-score, and I'm going to put it into the formula for z-score. So our formula, I'll put it here in the middle, z is equal to x minus mean over standard deviation. Okay, and we know our x's. We know our x's for both of these. We have 7 and we have 6. So remember, I brought this one over here. So this one, my x is going to be 6. So my z is negative 1.28. My x was 6. I do not know my mean, and I do not know my standard deviation. Okay, and then this one, my z-score is negative 0.842. My x, that came from this one, my x is 7. And I do not know my mean, and I do not know my standard deviation. Great, I have 2 equations I can't solve. But there are 2 equations with 2 variables. It's a system of equations. So what we can do is we can find the intersection of 2 lines. So I got to rewrite these, though, in a way so that I can put them into my graphing calculator. Or you could do it the long way and actually solve it using substitution. But I'm just going to rearrange these so that I can put them into my graphing calculator. And this is actually going to be really smooth. I'm going to multiply both sides by the standard deviation, and then I'm going to divide both sides by negative 1.28. These are just going to switch. So I'm multiplying both sides by the standard deviation and dividing both sides by negative 1.28, and I get standard deviation is equal to 6 minus the mean divided by negative 1.28. Okay, if you don't believe me, do it the long way, and it works. All right, multiply both sides by standard deviation and divide both sides by negative 0.842. I'm left with standard deviation is equal to 7 minus the mean divided by negative 0.842. Now, since these both equal the same thing, I can set them equal to each other. So they both equal the standard deviation, so I can now use substitution and say 6 minus the mean divided by negative 1.28 is equal to 7 minus the mean over negative 0.842. Oh, I'm starting to run out of room. And then I'm going to put this into my calculator. So on my calculator, I'm going to go to y equals, and I'm going to plot these as two separate lines. So my first line, I'm going to put it in parentheses. Oops, where am I? I better put on my glasses. I can't see what I'm doing here anymore. Okay, so for my first line, I'm going to have 6 minus, I don't have a mu, so I'm going to use, or whatever that's called, I'm going to use an x, all divided by negative 1.28. And then the other one, 7 minus x, notice it's in parentheses, all divided by negative 0.842. And now I'm going to graph it, see where they cross each other. There's the first line, here comes the second line, bam, they cross each other. So where they cross each other, the x value is going to be our mean. So I'm going to go second, trace, intersect, first curve, second curve, there it is. They are intersecting at x equals 8.92. So from my graphing display calculator, I'm going to get the mean is equal to 8.92. And now I can just plug that in for either here or here and find the standard deviation. Oh, actually, the standard deviation is just going to be the y value, now that I think about it. So what's the y value? There it is, 2.28. Because see, y equals 6 minus x divided by negative 1.28. Oh, brilliant. I don't even need to do any more work. So my standard deviation is, what was it? 2.28. 2.28. All right, there you go. Only took me 28 minutes to do those 4 examples. And so now it's your turn. So all the work that you're going to be doing today, it's just a bunch of playing with the calculator. Thursday and Friday, we're going to spend the whole time doing word problems that are using normal distribution and binomial distribution and trying to determine when do you use which one. All right, and that'll get us to spring break. All right, hope you enjoyed the show, and good luck with doing these on your own. I will give you all the answers so you'll know that you're right or wrong. All right, thanks. Take care. Bye-bye.